Guys, what's poppin' here? Today we are trying to implement queue using array in Python. So we are asked to implement a queue using the given array of size n. The queue must support the following operations. Before we see the following operations, it would be better if we had a basic understanding of queue. So let us just take a look at what is given here. Essentially, they will give a sequence of queries and the queries are represented in a numeric form. We just have to implement the functions enqueue, dequeue, getFront and everything that's given here, and the driver code will handle the output. So now let's take a look at the concept. So what is a queue? A queue is a linear data structure that follows first in first out format. So what is first in first out? First in first out is like for example, when we are standing in a queue, if we reach the queue first, we exit the queue first. So like let us take this example. There are 4 spaces. The person who enters first leaves first. So there are a few basic operations in queue. Now let us look at that. These are the basic terminologies that we will be using in a queue. So what is front? Front is the starting position, that is the 0th index. When we are taking an example of array, the 0th index will be front. The first position in a queue is called as front. The same way, rear is the last position in a queue. So the last. Now NQ and DQ are operations that we use to add elements to the queue. NQ adds values to the last element. That is, if this place is empty, NQ adds values here. Why does NQ, or when we add new elements to the queue, it adds in the last? Because it follows first in first out principle. So it adds the new values to the last does not essentially mean the final position. It just means if there is 3 of the spaces filled, it adds the new value here. If just 2 of the spaces are filled, it adds the new value here. So it adds the value to the end of the queue. That is the basic meaning of enqueue. Similarly, dequeue removes the first value of the queue, because it follows the FIFO order. Since this is in the starting of the queue, when we are removing a value, we remove from the start of the queue. When we use peek function in a queue, what it does is it returns the first value of the queue, that is the value in the top of the or the front of the queue, without removing it. We just use it to look at the first value, that is the value that is in the top of the queue. Now what is empty does is it checks if the queue that we have is empty or not. It basically checks if there is any values in our queue. Is full checks if our queue is full or not, that is if our queue has reached its maximum capacity. That is all the basic terminologies that we need to know to understand queue. So queues can be implemented using different types of data structures. For example, arrays, linked lists, in some special cases stack, and dequeue. There is one more important concept in queue called as circular queue. A circular queue is nothing but a queue where the rear, that is the end space, points to the starting space. So basically it is queue but in circular format, where the front and the rear point to the same space. So that is all the basic concepts of queue. Now let us look at how to implement queue in Python. So here we are defining different data structures for the ease of the creation of a queue. Here we have defined self.array and self.size, self.n, which will be equal to n, and then I will initialize a different variable for the size called self.size, which will be which value initially will be 0. So now let us try and define the isEmpty function of the queue. We return true or false according to the size of the queue. So if the size of the queue is 0, we return true, or else we return false. And that is the essence of the isEmpty function. Now looking at isFull function, similarly we return true or false according to the spaces occupied in the queue. So if the size of the queue has reached the maximum, that is n, we return true. Now if we look at nq, we state a function, we state an if condition stating if the queue is full, we cannot add more elements, so we return. Now before we define the logic for nq, let us start dq. So similar to nq, in dq we check if the queue is empty, so that if the queue is empty, we cannot remove any element from it. So if the queue is empty, we return without performing any function. And then if the queue is not empty, what we do is we take the front element and then we move the front element's pointer 1, because removing an element is less efficient rather than moving the value of front. So when we see or return the value of front, we essentially omit the original front and then we display the updated front. So and then we reduce the size by 1, so that without removing any values, we are just manipulating with the variables. Now going back to nq, if the rear element is there, we add the value of rear by 1, essentially adding a new value, and then we update the new rear value. The given new value is x, and then we update the size by adding it with 1. And then when we look at get front function, if the queue is empty, we are checking if the queue is empty using the isEmpty function, we return -1 because there is no value in the front of the queue. If there is values in the front, we return the value of the front of the first element. And then when we look at the get rear function, similar to the get front function, we check if the given queue or the queue that we have is empty. If it is empty, we return 1, and if it is not, we return the final or the last value that is there, that is existing in the queue. So this is essentially the entire implementation of queue using arrays in Python. When we run it, the sample test cases all pass. So that's all for today, guys. Hope you guys enjoyed it. See you in the next video. Bye bye.